Okay, so now let's look at another example of doing an integral over a non-rectangular region. Right. So this time we want to compute this integral over d of x dA, where d is the region between these two parabolas. So what's step one? Hopefully you remember it's sketch the region. All right, so let's go ahead and sketch the region. All right, so this region is given by two parabolas, and those two parabolas look like this. The first one, or I guess this is the second one written, this one is y equals 1 minus x squared. Right? It's an upside down parabola because of the minus, and the 1 raises it up 1. Right? And then we have the other parabola, x squared minus 1, which is a normal parabola moved down 1. So that looks like this. Right? So this is y equals x squared minus 1. Right? So we get this new region inside here. That's what we're integrating over. So here's where it pays to think carefully about how you want to set up your integral. Do we want to set it up as dx dy, or do we want to set it up as dy dx? Right? So this double integral, x dA, this is going to be x d something else. Right? Which way do we want to do it? So let's say we did dx first. Right? That means going left to right. So up here, well, there's already one interesting thing happening. We start on the pink parabola and end on it. All right? And that happens all the way till we get to this point. And then we switch parabolas, and now we're going from the left to the right on the orange parabola. So it'll actually be really hard to write that down in just one integral. And as a matter of fact, we'll have to split that up into a sum of two different double integrals. One for the top piece where the bounds are given by the pink parabola, and one for the bottom piece where the bounds are given by the orange parabola. So, doing x first in this case isn't such a great idea. So what if we do y first then? What does that look like? Well, in this case, our slices go this way. Right? I'm just drawing multiple slices here so you can see. And the important thing to notice is they always start down here on the orange one and always end up here on the pink one. Right? That never switches. Right? It never all of a sudden starts on the pink and then ends on the orange. Right? It's always from orange to pink, which is great. So now we can write this all together in one integral. So we'll do dy, then dx. All right? So now how do we set up these bounds? Remember y goes from bottom to top. So the bottom guy here is the orange parabola, which is x squared minus 1. Right? And then the top one is this pink parabola. Right? It's the top up here on the region they bound. And that's 1 minus x squared. Right? And again, notice there's no y's in either of these, and there never should be, since y is the thing we're integrating with respect to. All right, and then now how do we set up the next bound? Remember, it's just the full range of possible x values. So x can go all the way from minus 1, and it spans all the way until we get to 1. Right? And that's it. So now we just do the integral. Well, if we integrate x with respect to y, we just get xy. Right? So this is just xy from x squared minus 1 to 1 minus x squared dx. Okay? So that's the integral from minus 1 to 1 of, well, x times this. So x minus x cubed. Let's do this here. Right, and then minus the lower bound, x cubed minus x. All right. So this is the integral. I'm going to move over here now. From minus 1 to 1 of 2x minus 2x cubed dx. All right. I'm pretty sure you can do this, so I'll just go ahead and do this here. Not minus a fourth, because there's a 2 out there. So this would be minus a half x to the fourth from minus 1 to 1. And that gives us, well, 1 minus a half minus 1 minus a half, which is 0. All right? So we get 0 here. What does that mean? Well, notice this isn't a volume because the function x is positive over here but negative over here. So you can actually kind of explain this away by what's called symmetry, right? So maybe you might remember in Calc 1 or 2 integrating even and odd functions. Like remember if you integrate, say, sine from, what do we got here? Minus pi to pi, you get 0 because sine is an odd function. Or even better, x cubed. If you integrate x cubed from minus a to a, you get 0 because x cubed is an odd function, right? And then if you integrated x squared from minus a to a, that's the same as just twice the integral from 0 to a. Right? So these are kind of the symmetry sort of things. And there's a similar kind of idea here. All right? So the function x, that's an odd function with respect to the y-axis. Right? So what that kind of means is if you pick a point over here on this side of the y-axis and you reflect it across to this side of the y-axis, x takes opposite values. So if it's 5 here, it's minus 5 here, for example. All right? And notice also that this region is symmetric about the y-axis. So it kind of means like if you fold it along the y-axis, it fits up nicely, folds exactly in half. So you can also tell that this integral should be 0 by symmetry there. Since x is odd with respect to the y-axis, and this region is symmetric with respect to the y-axis, you get 0. Right? So those are two different ways of getting the same answer. Right? And the symmetry can help you later on when we're doing like moments of mass and inertia and stuff like that. Okay? See you in the next video.